Hello, and welcome to another lesson in our Information Technology series on the Practical Assessment Task, or PAT. Just to remind you where we are so far. We looked at the details of Phase 1, and we have learned a lot about Phase 2 already, from program specifications to IPO tables. Today, in the first of 2 lessons about classes, objects and data flow, we will draw up class diagrams for objects that will be used in a program. Later, we will create diagrams to show the data flow between elements in the program. By the end of this lesson, you should be able to understand classes and objects used for data storage in object-oriented programming. Explain the advantages of data encapsulation, and differentiate between private and public members of a class. In previous lessons, we created IPO tables for all the algorithms or events in your PAT. Let's check Tabo's progress. And how are we doing on the IPO tables?
Just finished the last one. Phew, what a job.
It's time-consuming, yes, but trust me, you need the IPO tables to move to the next step in Phase 2, creating class diagrams. But first you need to understand objects and classes. You said that your educational program for the PAT would use IT terms and definitions from grade 10, 11, and 12 levels. Are you going to teach, drill, or test the terms and definitions?
I'm mainly going to test the user. But if a user repeats a test, that will be drill and practice.
I suppose that if the users see the correct terms and definitions together after a test, it could be a form of teaching?
Yes, the user is going to do multiple choice tests or matching the columns, stuff like that. But I want it to be more like a game than a normal test.
Well, it sounds as though the main function of your program is testing, drilling, and teaching IT terms in a game event. For any one game event, you will need a selection of terms and definitions from your database that you can use in a few different ways. First for testing, then for showing the correct answers for the test. You'll also need to have some input data available, like the type of test the user has chosen, so the test can be presented in a particular way.
I'll definitely have a database with terms and definitions, and I'll choose some of these for each test, maybe 10 or 20 at a time. I want to use text files to store things that must be stored, but that don't belong in the database. I'm thinking of having a text file for each player to store things like the terms they get wrong, so they could print a list of items to learn.
What about the data the user provides?
Input data. There are 2, for sure, like the type of game that you mentioned, or maybe the user will be able to set a time limit for the game.
So a selection from all data will be used for the main function of the program. In this case, let's say a multiple choice test.
Yes, definitely.
As a programmer, you need to make sure that you use the RAM efficiently. Now, wouldn't it make sense to collect all the data needed for a game and keep it in just one location in RAM while the game is played, instead of having to keep fetching it from the database, text files, or an input source over and over again as the game proceeds?
I find it difficult to remember the names of all the variables I have to use. If only I didn't have to think about all the bits and pieces of data all over the place.
Good news, you don't. I'm going to show you how you can just refer to the storage location in RAM of a whole collection of data items and say what you want done.
That sounds too good to be true.
Not only is it true, it's also a better way of using the RAM. Make sure before the game starts that data is protected from being accidentally or deliberately deleted or modified by either the program or the user. Predefine the tasks that repeatedly use the data in the same way, For example, getting the data into the RAM from all the different sources.
Or if we have to find correct definition for a term over and over again.
Thabo, it would be nice to pre-write the code saying how that it must be done.
Then I could just tell the program to do it. I wouldn't have to keep giving the same set of instructions.
Yes, it will then be easy to free up the RAM when the data is no longer needed.
Oh, cool. Because having things in a RAM that are not being used slows down the processing of other data.
A good program will use the RAM efficiently by storing separate data items needed for an event in one logical place. Protecting the data from unwanted modification or deletion. Predefining tasks that collect, modify, use, or delete the data. And freeing the RAM easily when the data is no longer needed. What we need to do is create one or two objects that can each hold many data items. A program that uses objects for data storage is what we call an object-oriented program. Your patch should be an object-oriented program. That means the program takes data from its main function, from the database, text files, or input data, and stores it in objects in RAM. Let's make sure we know what a data storage object is. An object has a number of attributes or fields of different data types.
Hang on. Does that mean an object is similar to a record in a database table?
In a way, yes. Both kinds of field can store data. The difference is that the data fields in a record can be accessed directly in several ways, depending on what the user or programmer decides to do. Data fields in a record can be accessed directly by using normal programming code, creating SQL text or strings to be used by an ADO query component in RAM connected to the database, or using database management software like MS Access. The user or programmer decides what to do. Data fields in an object are different in several ways. They can only be accessed by program code and usually only indirectly. An instruction in a program can call a predefined method of the object, but cannot decide what can or can't be done with the fields. The methods are functions and procedures or modules of code which predefine what may be done with the data in the fields. No other access to the data is possible. So an object consists of fields and methods of dealing with those fields.
What if the user accidentally deletes or changes fields?
That's not possible. The user has no access to an object. Even the program code cannot give input to or get output from the fields unless there is a method which allows it. If data is needed as input or provided as output by a method, it must be passed as a parameter. The programmer cannot use the names of the fields of an object in his own program.
So the fields and the data in those fields are hidden from the program?
Yes, Thabo. This concept of isolating and protecting the data from the rest of the program is called data encapsulation. It is obviously a good thing to protect the data used in a program from unwanted deletion and modification by encapsulating it in an object. Back to the PAT. Say your PAT uses a multiple choice test. How many terms and definitions do you think you'd have to take from your database where you have stored hundreds of terms and definitions for the 3 grades?
15 to 20 of each easily. One for each question I ask.
That's right. Each of these terms and each of their correct definitions will be a data item. These data items are essential for the game to work properly, right? If we were using only one term and one definition, we would need one object to store it in. We could call this a gameplay object. When the program uses multiple similar data items, such as many terms and definitions, we store the data in an array of objects. Multiple similar data items need an array of objects stored in RAM, like, for example, an array of gameplay objects. And when the player or administrator logs on, do we have multiple similar data items to store?
No. My games can only be played by one person at a time, and there will only be one admin user. I'd have to control access to certain screens with a password.
So you need a single instance of an object to control access. Use this to see if the person trying to get access to a screen is a player or an administrator. To make it easier, you'd call it an object admin. What if you want to use the player's first name throughout the game in messages, or maybe store her total score?
Well, I don't need to do that for the administrator. So I'd need a different object, like a player object.
That's correct. We use, for example, the admin object or player object for single entities. The admin object can be used to control access to parts of the program. The player object can be used to store player details needed throughout the program. In the previous lesson, we drew up IPO tables for all the events in your PAT. Now we have to define the classes used to create the storage objects you mentioned in your IPO tables. There is a big difference between a class and an object. How can I simplify it? Let me see. An apple. Can you define or describe an apple? Not this particular apple, any apple.
It's hard and round, and the skin can only be a shade of red, green, or yellow. The pips are on the inside, and the flesh is white, crisp, and juicy.
Good description. So does this object I'm holding have all those properties?
Definitely.
Now, what are some of the things that could be done to any apple? Things done by or to the properties?
It can be cut or peeled. Its skin and flesh can be eaten, or the flesh can be turned into juice. The pips can be planted. You could even polish the skin to make it nice and shiny, or the flesh could rot away. You could also use it as a weapon and throw it at someone, or...
Okay. Let's not get carried away. We call those things behaviors. Things done by or to the properties. Now, this apple and any other apple that actually exists is what we call an object or an instance of the apple class. My lunchbox is not an instance of the apple class because it does not have the properties or behaviors associated with the apple class.
Oh, okay. So the class is the definition of properties and behaviors for a certain kind of thing?
Yes, and the object is an instance or actual example of something from that class. Think of the class definition as the blueprint or plan for creating and using objects of a particular type. Today we're going to use the IPO tables to illustrate the structure of a class definition so that we'll know what those blueprints should look like.
And then can we start programming?
You only have to write the actual class definition units for your PAT in phase 3, Tabo. We're only looking at structure, not the code. The program will use the blueprints or class definitions provided to create the objects, but more about that later. Let's take a closer look at a class. A class has attributes, the fields or properties to store data, and methods or behaviors to give instructions for ways of handling the data.
How does this relate to programming?
When we write code to define our classes, we use variables as the fields. The methods will be procedures, functions, and constructors.
Oh, yes. We learned about procedures and functions in our lesson on algorithms.
Let's first take a look at where we should save this code. That should help us to understand what kind of methods we should use.
I'd save it into my program code.
You could put your class definitions directly into your program code, but as we saw in the previous lesson, programs should be modular.
Of course, yes. So we could reuse modules in different parts of a program, and even in other programs.
Yes, Thabo. So the best place to store your class definitions is in a separate unit or module of code, saved as a separate file. When we define our classes, we can define more than one class in the same module of code. Look at this example. Here we have 3 classes in the first module and 2 classes in the second module. A class can be a subclass of another class, which means it can inherit all the fields and methods of that class, and it has some additional fields and methods of its own.
I don't follow.
Say class 1 is a fruit class, and class 2 is an apple class. The apple class defines an apple as being round in shape, but it inherits the property of being edible from the fruit class. So an apple class is a subclass of a fruit class.
Ah!
The fields and methods of a class are known as the members of that class. The members of a class can be private, protected, or public. Let's take a look at an example of a class to see what this means. Remember that data will be encapsulated to protect it from unwanted modification or deletion. Here we use arrows to show what access is allowed to the members, the fields and methods of class 1, which is shown shaded in blue. Having access means being allowed to read from or write to the variables storing the data in the fields, or calling a method which has been defined. So, to state this simply, if a member of a class can be named or called, it means it can be accessed. The fields are simply storage locations, so only an instruction in a method or an instruction in a program can try to access something. In this diagram, we can see that there are 3 kinds of access to the members of class 1. If some of the fields and methods are placed in a private category, only the methods in that class have access to them. If fields and methods are placed in the protected category, they can be accessed by the methods of that class and any subclass of that class. If fields and methods are placed in the public category, they can be accessed by any method of any class or by any program code which chooses to use the class. In grade 12 IT, we only have to differentiate between what is public and what is private. We don't need to worry about protected members of a class. So here is a modified diagram. The instructions in a program can only get access to the public fields and methods. If we want to make sure that the data in the fields is well and truly protected from any of the programs, we can simply make sure that there are no public fields, like this. Members of a class can be private, only methods of the same class can access them. Public, any code can access them. Now all we have to do is make sure that the public methods are well written. How would the program store data in an object of its class?
It'll have to pass that data as parameters, and will only be able to do that if the public method it calls allows it.
Yes. It can also only retrieve data from the object if there is a method which allows this to happen. Looking at this, we can see that the public methods act as an interface between the program code and the private members of the class. That's all we have time for today, but here's a task about the lesson. You are creating a program using object-oriented programming to display and make calculations with test marks. The data is saved in a file called marks.txt. Study the data in marks.txt. 1. Create an object class, another unit named CLS tmarks. 2. Define a class named tmarks in this unit. This class must contain the following private fields: surname : string, test1 : integer, test2 : integer, and test3 : integer. 3. Also create the following public methods: constructor create, overload, constructor create p surname : string, ptest1, ptest2, ptest3 : integer, overload, function get average : string, function show marks : string.